Regression analysis is a fundamental statistical method used to understand and model relationships between variables. It helps us predict outcomes based on input factors. To understand regression, we visualize data on a coordinate system. The horizontal axis represents our independent variable, the factor we use to make predictions. The vertical axis shows our dependent variable, what we want to predict. Here we see actual data points plotted on our graph. Each point represents an observation where we have both x and y values. Notice how the points tend to follow an upward pattern. Regression analysis finds the best line that fits through these data points. This line represents the mathematical relationship between our variables and allows us to make predictions. The mathematical form of regression is expressed as y equals beta 0 plus beta 1 times x plus epsilon. This equation captures the linear relationship between our variables. In this equation, y is our dependent variable that we want to predict. X is our independent variable that we use for prediction. Beta 0 is the intercept, and beta 1 is the slope that shows how much y changes when x increases by 1 unit. The primary purpose of regression analysis is prediction. Once we have our regression line, we can estimate y values for any given x value. This makes regression a powerful tool for forecasting and decision-making. Regression analysis reveals how changes in one factor are associated with changes in another. This fundamental concept forms the basis for predictive modeling across many fields, including economics, science, and business analytics. Regression analysis comes in several different types, each designed to handle specific kinds of relationships between variables. Linear regression models straight-line relationships between variables. It uses the familiar equation y equals mx plus b, where the line best fits through the data points. Multiple regression handles situations with several independent variables. Instead of just one x variable, we can include multiple factors that all influence our prediction. Nonlinear regression captures curved relationships that don't follow a straight line. This includes polynomial, exponential, and other complex mathematical relationships. Regression analysis has powerful applications across many different fields and industries. In economics, regression helps predict economic growth, inflation rates, and market trends by analyzing relationships between economic indicators. Financial analysts use regression to assess investment risk, optimize portfolios, and predict stock prices based on market factors. Marketing teams apply regression to analyze consumer behavior, optimize advertising spending, and predict sales based on various marketing factors. Healthcare researchers use regression to identify risk factors for diseases, evaluate treatment effectiveness, and predict patient outcomes. Regression analysis is a versatile and powerful tool that helps us understand relationships in data across virtually every field of study and industry.